I want us to look at a concept called completing the square. This is actually the fourth way in which to solve a quadratic equation. We just didn't spend time learning it in class. So there's a couple of things that I want to talk about before we get into that process. So what if I ask the question, what if we wanted to solve x minus 3 quantity squared equals 7 by the square root method? Remember, the square root method means that I want to get that square completely by itself, so then I can take the square root. Notice that we haven't seen anything like this before, but I've got parentheses where x minus 3 is inside of it, and then it's being raised to the second power. Because all of the numbers on the left side are inside that are inside the parentheses, that means that I have that squared term isolated by itself. So what I get to do then is I can literally just take the square root of both sides. When you take the square root of a square, those cancel, and it's going to leave us with what was underneath that radical. So for us, that's what's inside of the parentheses. So we'll have an x minus 3. On the other side, don't forget that we will always have two answers, both a positive and a negative. But if we try to take the square root of 7, we're not going to be able to have anything simplify in our calculator. It's not what we call a perfect square. So we're going to leave it as the square root of 7. The last thing I have to do is get the x by itself. So because there is a 3 on the same side, I'm going to move that negative 3 by adding it. That will get rid of it, giving me the x by itself. Now here's the thing, that positive 3 that I just moved over to the right and the square root of 7 are not what we call like terms. I'm going to put that single 3 first, then I want that plus or minus sign, and then we'll keep the square root of 7, and these are actually two answers, and that is my final answer. Because remember, when you have a quadratic, because it's degree 2, you should always have two answers. Well, notice that that plus or minus sign in the middle here is what allows me to see that I actually do have two answers. I really, if I wanted to break it apart, can think of it as 3 plus the square root of 7, and I can also think of it as 3 minus the square root of 7. So you can write them separately like this, but I usually just write that plus or minus sign in the middle, and that's us taking the square root of something being raised to a square when it's in parentheses. So that's going to come and help us in a little bit. But the next thing I want to talk about is something called the square of a binomial, is when the trinomial can be factored into the same binomial twice. We call these trinomials perfect squares. So say I was looking at this example, x squared plus 20x plus 100, and I wanted to factor it. Well, notice that there's technically a 1 in front of the x squared, so there's not going to be a number in common. Because the 100 doesn't have a variable, there is no GCF. So that means you're looking for two numbers that multiply to 100, but add to this number in the middle, which is 20. So if you think about it, what multiplies to the number 100? Well, one of those numbers is 10 times 10. Notice that if I was to add those two numbers together, it's going to give me the 20 that I'm looking for in the middle. So that means I want to take these two numbers, put them into my parentheses. We'd start each of our parentheses with an x, and then we have to finish both of these with a positive 10. So notice that, like it says above, we have the same binomial twice. And so when that's the case, you actually get to write that as x plus 10 quantity squared. Notice that that looks kind of familiar. We just did that example right above. Notice that x minus 3 quantity squared is something called a perfect square trinomial. It factored into the same binomial twice. So we just wrote it once and we put the square at the end. So I'm going to combine these two concepts together, and now we're going to talk about this idea of something called completing the square. Completing the square is a process used to form a perfect square trinomial. The goal is to be able to use the square root method by creating these perfect square trinomials. We are going to use this method when we have a quadratic that cannot be factored and we decide not to use the quadratic formula. So let's look at this example. If my question is, how do we solve the quadratic equation x squared plus 2x minus 34 equals 0? Normally, when it's all to one side and equals 0, you try to see if you can factor, especially with there just being that 1 in front of the x squared. But if you're looking for numbers that multiply to this negative 34 and add to 2, unfortunately, you're not going to be able to find it, because when you're thinking about numbers that multiply to a negative 34, your options would be 1 and 34, with one of them being negative. So either the negative 1 or the negative 34. But if I try to add either one of those sets, I'm not going to get it to be the number 2. The other option is multiplying negative 2 times 17. That gives you negative 34, or switch the signs around and you have negative 17 times 2. But once again, if you try to add those numbers, you're not going to get 2 in the middle. That's the only way to get to multiply to negative 34. So, because this is not factorable, I am going to show you now this idea of completing the square. So what we want to do in this case, first and foremost, is we actually want to move the number that does not have an x over to the other side. So that negative 34, I'm going to move it over by adding. That gives us then x squared plus 2x, and then over here it now equals 0 plus 34 is 34. I am going to do this for a second. Because I want to complete the square, it means that I want to turn those two terms, the x squared and the 2x, I want to turn that binomial into a trinomial, so into 3 terms, which is why I need that extra little blank spot. But because this is an equation, if I'm doing something to one side, I have to do it to the other. So when I end up adding a number on the left, we also have to add it on the right. So now we have to figure out what is the number that I need to add to both sides. The process to do that relates to this 2 that is connected to the x. I am going to take that 2, I'm going to divide it by 2, and then I'm going to square it. So if I take it step by step, in parentheses, 2 divided by 2 is 1. If I square the number 1, it's really 1 times 1, which is 1. So that's the number I'm going to add onto the left, which means that's the number I'm going to also add onto the right. By now creating this trinomial on the left-hand side, what we have now, if I write it over here, so x squared plus 2x plus 1 equals, if I add on the right, 34 plus 1 is 35. But if I look at this trinomial on the left, notice that I can find two numbers that multiply to 1, but add to 2. Notice that the number that multiplies to 1 would be 1 times 1. If I add those two numbers, I get the number 2, which is why it turns into x plus 1 times x plus 1, and this equals 35. What I was talking about, though, a little bit above is we have the exact same binomial, which means that I can really write it as x plus 1 quantity squared, and that equals 35. Before I finish solving, I do want to point something out. Notice that the number that I had in the parenthesis prior to squaring it ended up being the number that I had in the parentheses when I wrote what my factored answer was. It might be a little bit hard to see in this particular example because the number is 1 and so it didn't change, but you'll see in the next couple of examples that there's going to be a relationship between the number that we had prior to squaring it and the number that then becomes our factored answer. Okay, so getting back to this, because x plus 1 quantity squared equals 35, it's just like that very first example that I showed you. We are now going to complete the square by doing the square root method. So I'm going to take the square root of both sides. That allows me to get rid of the square and the parentheses, and I can just write x plus 1. When I take the square root of both sides, we have two answers, both a positive and a negative. The square root of 35 is not a perfect square, so it's going to stay as it is. Last step I have to do is get the x by itself. So I am going to subtract 1 to both sides. That gets rid of that 1, giving me the x by itself. When I write my final answer, I'm going to put that -1 first because then I want the plus or minus sign, and we'll keep the square root of 35, and this would be my answer. Okay, that was a lot of information to process. Let's try a couple more examples together and see if we can kind of get the hang of this pattern. So let's practice this next one. X squared minus 6x minus 42 equals 0. If I want you to solve by completing the square, I do not want that -42 on the left. I only want the x terms on the left. So to move a -42 over to the other side, we are going to add it. So that now gives me x squared minus 6x to equal 0 plus 42 is 42. But the whole point is I want to create a trinomial. And so if I'm going to add a number on the left, that means I also need to add a number on the right. To figure out what my number is, I look at what is attached to the x. Notice that it is a -6. I'm going to divide it by 2, and I'm going to square it. That's the pattern. Always divide by 2 and then square it. Well, -6 divided by 2 is -3. When I square -3, I'm thinking -3 times -3. That gives you a positive 9. So if I add 9 onto the left, I'm also going to add 9 onto the right. So then we now have this x squared minus 6x plus 9 on the other side. 42 plus 9 gives us the number 51. The whole point is that now on the left, it's factorable. What multiplies to this positive 9, but will add to this -6? Well, what multiplies to a positive but adds to a negative? Two negatives. A negative times a negative is a positive. Notice that if I add these numbers, I'll get the -6 I'm looking for. Notice that the numbers that we found in the chart match the number that we had prior to squaring it. That's what I was talking about as far as my pattern. Whatever number is inside the parentheses before you square it ends up being the numbers that work for my factored answer. So what we can do is instead of writing that binomial twice, I can write it as x minus 3, and I can put quantity squared. That equals 51 still. To then get rid of that square, we are going to take the square root of both sides. The whole point of taking the square root of a square leaves you with what was inside the parentheses, so x minus 3. We'll have both a positive and a negative. If you try to take the square root of 51, it's not going to turn into anything else, so that will stay as it is. Last thing we have to do to get the x by itself is add 3 to both sides. That gets rid of us dealing with a number connected to the x side. So that gives us the x by itself. We'll put that first number of 3. Then we'll do our plus or minus sign. We'll keep the square root of 51. And that would be our answer. So taking a look at the next example, x squared minus 20x plus 50 equals -4. Notice I want to get the 50 away from the x's. So to move a positive 50, I am going to subtract it. That gets rid of that. I still have x squared minus 20x. Now that's going to equal -4 minus 50 is -54. I then now want to start this process of completing the square. So I'm going to be adding the same number onto both sides. Starting with the number that's connected to the x, I'm going to take that -20, I'm going to divide it by 2, and I'm going to square it. That gives me then negative 20 divided by 2, which is negative 10. When you square a negative times a negative is a positive. So I am adding 100 to both sides. So now if we have x squared minus 20x plus 100, that's going to equal, if I add negative 54 and 100, it gives me 46. Now I can factor. So once again, we're asking what is going to multiply to the last number, but add to the number in the middle. You can go ahead and think about that thought process, but once again, it's actually going to turn into this number that we had prior to squaring it. It's going to be the number negative 10. Because once again, think about it. Negative 10 times negative 10 is a positive 100. That's going to add to the negative 20. So we really will have x minus 10 in parentheses, quantity squared, and that is what equals 46. Last thing we have to do then is get rid of the square. So we will take the square root of both sides, leaving you with what we had in parentheses, which was the x minus 10. On the other side, we will have two answers. If you take the square root of 46 in your calculator, it is not going to simplify any further, so that will stay as it is. Last step for us is to add the 10 over to the other side to get us the x by itself. We'll put that 10 first because then I want the plus or minus sign. We'll keep the square root of 46, and there is my final answer. Let's do one more example together before I have you try a couple by yourself. So if we have x squared plus 4x minus 21 equals negative 2, remember, start off by moving the number that doesn't have an x to the other side. So the opposite of a negative 21 is to add it. That gives you then your x squared plus 4x together on the left. On the right, negative 2 plus 21 gives us 19. We now are going to be able to start that process of completing the square. So we want to add the same number onto both sides. To do that, we look at the number that is attached to the x. I want to take that 4, I want to divide it by 2, and I want to square it. Well, 4 divided by 2 is 2, and 2 squared, which is 2 times 2, gives us 4. So that's the number I'm adding to both sides. Remember, that gives us then x squared plus 4x plus 4 on the left. Add those two numbers on the right. 19 plus 4 is going to give us 23. You can go ahead and try to factor by thinking what multiplies to the last number but adds to the number in the middle. But remember, there's a connection. It's the number that we had prior to squaring it. Hopefully it makes sense. 2 times 2 multiplies to 4. 2 plus 2 gives you 4 as well. So I'm going to take x plus 2, quantity squared, and I'm going to set that equal to the 23. To get rid of the square, we are going to take the square root of both sides. That leaves you with what was inside the parentheses on the left. We will have two answers on the right. So we'll have both positive and negative, and we'll still keep the square root of 23. Last step to get the x by itself is to subtract 2 from both sides. That does give you x to equal. We'll put the negative 2 first, then the plus or minus sign, and then the square root of 23. And there is my two answers. Here are two problems I want you to try. So please pause the video, try these problems, and then you can unpause the videos to check your answers. So please pause now. All right, hopefully you paused and now you are looking to see if you had the correct answers. So these were the two answers that you should have had. You should have had for the first one, x equals negative 4 plus or minus the square root of 71. And in the second example, you should have had x equals 6 plus or minus the square root of 5.